Okay, problem 65 is a cute little problem. We've got this track, right? It goes something like that. And we got a block here, and we let it go, and it slides without friction down to here, where it hits this, where there's friction, and it slides across, losing energy. Then if it has enough energy, it's going to go back up some, and then it's going to come back. Okay, so all the energy lost happens in this frictional part. Anytime we come to the end, all we do is convert kinetic energy into potential energy and then back into kinetic, and then we lose it again as we slide, lose energy again as we slide across. So what is the total energy available to us? Well, mgh, right, which in this case is mg times L over 2, is the total energy available to us, right? All right. How far from the left edge of the flat part does the particle finally stop? Well, it stops when we've done this amount of work on it. So what's the work that gets done on it by friction? All right, the work done on by friction is mu k mg times the distance it travels on the frictional part. All right, and this is actually negative work. It's actually negative work. So we're looking for the point where u plus w equals 0, or mg times L over 2 equals mu k mg times x. Okay, so the mg's cancel out. We're left with L over 2 equals mu k x, and so the distance from the left-hand side, the amount of distance it's traveled from the left-hand side that it goes before coming to a stop, is L over 2, right, times 1 over mu k. 1 over mu k. That's the total distance it travels. Now, this distance may be greater than L, right? Let's take a look. This is going to be 40 centimeters divided by 2, 2 times, what is it, 0.2 equals 40 centimeters divided by 0.4, right? So 40 divided by 0.4, let's go with 40 divided by 0.4, and we get, okay, 40 divided by 0.4, and we get 100 centimeters. Now, it asks how far from the, right, this flat section is 40 centimeters, and we got 100 centimeters. What does that mean? That means it came down, it made it all the way across, all right, that's 40 centimeters, went back up, it came down, it made it all the way across, that's 80 centimeters, it went up, came back down, and it went 20 centimeters. So the answer to this is that the object stops 20 centimeters from the left hand edge of the flat space. Right? 20 centimeters from the left hand side. So it goes all the way across, all the way back, and back across. And this equation works because when it goes up the slope and back down, energy is conserved, and it comes back to this point going the same velocity but in the opposite direction that it was heading when it left. Okay, that's it for problem 65, and we're done.